Alright, so now we're going to start our unit on chemical reactions. Again, I'm going to go through this pretty quickly, so you may need somebody to pause. That way you can take the notes, or rewind and take notes, or whatever you have to do. So right now I want you to go ahead and get out a piece of paper and a pencil if you haven't already. And we're going to take some notes on chemical reactions. So the first thing that we need to know is the different signs of a chemical reaction. Just because you throw two things together doesn't mean that they're going to react. They may not react at all. But here are some signs that a chemical reaction has occurred. You have color change, precipitate of a solid, so that just means if you put two liquids together, it becomes cloudy, and that cloudiness is actually a solid. We'll look at that in class. Energy changes, so heat being produced or light being produced. Odor changes, so it produces a smell that wasn't there previously. And then also gas being released, so bubbles being formed, and that is a gas being released. So these, again, are signs of a chemical reaction. Just because one of these things happen doesn't mean that you have a chemical reaction. For example, if you're boiling water, gas is released, but that's not a chemical reaction. You just have the water going from liquid to a gas, forming a bubble, and then rising to the surface and popping. That's not a chemical reaction. So the more of these things, these signs that you have, the more likely it's going to be a chemical reaction. So in general, there's just two main parts of a chemical equation. There's the reactants, which is the substances that exist before a chemical reaction occurs. So the things that you start with, those are your reactants. And then your products, those are the new substances that have formed after the chemical change. So a chemical equation just indicates which ones are the reactants and which ones are the products. And a way that you can always tell is looking at the arrow. The arrow is always going to point to the products. So the arrow always points to the products. The reactants are then on the other side. That's what you start with. So we can write chemical equations out as word equations. So a word equation just describes the chemical change using the names of the reactants and products. So if we look at this, we have methane and oxygen. So methane and oxygen. And what this arrow is saying is yields or produces carbon dioxide and water. So you have your reactant side and your product side. This reaction is really what happens when if you're at home and you have a gas stove, the gas that comes out is the methane plus the oxygen that's already in the air, and then you ignite it, and what's produced is carbon dioxide and actual water vapor. Water is a gas form. So those word equations are used, and they're actually used quite often in the AP. What's used more often and more common is chemical equations written in this form with just the symbols. So you have the symbols there, and they represent the formula for that compound or that element. And then you have all the different numbers that evolve or go with them. So if we look at this example in these numbers, now we have this big number in front, and you see that occur in each case. And then we also have the small numbers that we're used to. So I just want to make sure that we understand what do all these numbers mean and how are we going to use them. So the big number in front, that's going to be the coefficient, and that's the number of that particular molecule that I have. So this 2 here in front of the H2O means that I have 2 of this molecule, H2O. So I don't have just one of them, I have 2 of them. The subscript, the little small number, is just telling me how many atoms of that particular element. So this 2 here, we should already realize that just tells me how many hydrogens only that I have. Oxygen doesn't have a subscript. If an element doesn't have a subscript, we should assume it to be 1. Okay, so let's see if we can use these new numbers, especially the coefficient, to be able to identify how many of each particular atom I have. So I have a couple of examples set up for you. So if you take a moment and write all these examples down, we're going to go ahead and calculate how many carbon atoms or oxygen atoms of each element that we have in each one of these formulas. Okay, so let's look at this first example here. It says I have 4 carbon dioxides, or 4 CO2s, and they want to know how many carbon atoms then do I have and how many oxygen atoms then do I have. And remember, this 4 here is telling me that I have 4 of this entire compound, the whole carbon dioxide. So I have carbon dioxide 4 times. So I have CO2, 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 CO2. And if I look at that, and I just count up how many carbons I have, 1, 2, 3, 4, that gives me my answer. I have 4 carbons, or I have carbon 4 times here. And then if I count up my oxygens, well, this oxygen, there's 2 of them. So each time I have that happen, I have 2. So that's 2, 4, 6, 8. 8 oxygens. So you could draw them out each time, like I did. But that's going to take a lot of time and a lot of paper to do that, especially if we look at the next one. So what I recommend you doing is just realizing, okay, this 4 in front means that I have 4 times of everything. So I have 4 times my 1 carbon, 4 times 1, 4. And then I have 4 times my O2. So that's 2 times 4, it gives me 8. Let's move on to the next one. The next one, you may be thinking, oh man, polyatomics, got all this stuff going on. But it's really not too much more difficult than the first one. Okay, so I want to go a little slower with this one because the polyatomic does make it a little bit more complicated, but not too much more complicated. So if we look at the compound here that we have, inside the compound, the formula tells me, we have to remember that what these little numbers tell me. The little number here goes with aluminum, saying that there's 2 aluminums in this compound. But I have 5 of the compounds. That's what the big number in front is telling me. I have 5 of this entire compound. Well, every time I have the compound, there's 2 of them. So 2 times 5 gives me 10 aluminums. So that one might have been easy. But now we're to the carbon. And carbon's a little bit more difficult. So if we look at this carbon, inside of my parentheses, there's only 1 carbon there. But this number on the outside, this little 3 on the outside, is telling me that I have 3 of everything in here. So I have 3 times the 1 carbon, gives me 3 carbons. But I have this whole thing 5 times. This 5 goes to everything. So that 3 comes in, that's 3 carbons times the 5, 15 carbons. Now, if that was confusing, just watch this again. I'm going to do it with the oxygen. So I have 3 on the outside of my parentheses. It gets brought in, multiplied times my 3 oxygens. That 3 is with the oxygen, so I have 3 times. So 3 times 3, 9. And then the 5 again goes through everything. So 5 times the 9 will give me 45 oxygens, which is a lot of oxygens, yes, but that's a lot of molecules as well, 5 molecules. So that's how you get that particular one. Okay, so that one might have been a little complicated, but remember, you can pause this and rewind it. I would definitely recommend, if you have time, you rewatch this on your own, especially if you're not getting this part. So let's go ahead and do the last one here. So another polyatomic. Actually, we have 2 different polyatomics. So we have to remember what these little numbers are telling us, and then what the big number here is telling us. So when I'm looking for nitrogen, inside my parentheses, I have 1 nitrogen. There's no number with my nitrogen, so I know it's 1. But this 3 goes to everything inside the parentheses. So it goes to the N, and then it also goes to the H. So I have N, which there's 1, times 3, because of the parentheses. So there's 3, times 3, because this 3 goes to everything inside. So I have 1 times 3, which is 3, times 3, 9 nitrogens. The next one, hydrogen. This little 4 here is going with my hydrogen, so I already start off with 4. And then the 3 comes in, so 3 times 4, which is 12, times the 3, which is going to give me 36 hydrogens. At this point, people kind of get confused, so make sure you do pay attention. This 4, remember that 4 is going with the oxygen. There's no parentheses here, so it's not going with my P. There's only one P here. And the 3 still comes to everything, so 3 times the 1P gives me 3 Ps. Ending with my oxygen, I have 4 in my formula. I have the formula 3 times, so that would be 12 oxygen. Again, I would highly recommend, if you're not getting it, to rewatch this again and also practice on the homework. So why do we have to do this? Why are we messing with these big numbers? Why do we have to do that now? And what happens is it all boils down to this law of conservation of matter, saying that matter can't be created or destroyed, and so we have to be able to balance our chemical equations. Just meaning that whatever atoms we have on the reaction side, the same amount of atoms that we have on that side, we need that same amount of atoms on the other side, on the product side. So when we write out an equation, it may not be balanced. There may be too many hydrogens on one side. So we put these coefficients, so we add the coefficients in front to then balance the equation to make sure that we have the same amount of atoms on both sides of the equation. Because that's what this law of conservation of matter is telling us. We can't create matter from nothing, and we can't destroy it. Alright, so here's a picture of an unbalanced equation versus a balanced equation. And what we have here in this chemical reaction is H2, which is hydrogen gas, plus Cl2, which is chlorine gas. And what happens is this is the formula that is produced. It produces HCl. It doesn't produce H2Cl2, it produces HCl. And obviously from this picture, we can see that this is not balanced. And so what we have to then realize is, oh, what we do form is HCl, but we form 2 of them. We form 2 of the HCl's. So we just put a coefficient of 2 in front of the HCl, and then that makes this chemical reaction balanced. So I said that, and it sounds like I said it oh man, this is real easy. It's not really easy to do. So I want to do a couple examples with you to show you the way of how to balance it. This particular one is kind of easy, just because you only needed to add one coefficient, a coefficient of 2. Not every time is like that. So I do want to look at a couple of examples with you. Just follow along, and we'll get some practice in. Alright, so let's try this example from scratch. So I've already written the chemical formula up here, the chemical equation. So our reactant is water, and the water, we're breaking up the bonds, and it produces hydrogen gas, which is H2, and oxygen gas, which is O2. Those are the formulas. I can't change anything about the formulas. That's what the formulas are. What I can change is the coefficients, which is how many of those particular molecules I have. And so when I look at this, I want to see, is it balanced? Meaning, do I have the same amount of atoms of the same element on both sides? So when I look at hydrogen, I just need to make sure that all the hydrogens on one side equals all the hydrogens on the other side. And then I look at oxygen, and I look at how many oxygens I have, and they have to be the same number on both sides. Then themselves don't have to be the same number, so oxygens and hydrogens don't have to balance. Just the hydrogens with the hydrogens, and the oxygens with the oxygens. That's all that has to balance. So if I look here at my water, I know I have 2 hydrogens there, and I have 2 hydrogens on my product side. Good. That seems to be balanced. I don't have to do anything with there. If I look at my oxygens, I have 1 oxygen here, but I have 2 oxygens on my product side. Now those are not balanced. So I have to do something to change this. Well, some of you may think, oh, I could put a 2 down here. I can't do that. Then that would change my formula. I can't just put a 2 here because that would change my formula from water to hydrogen peroxide. That's not what I have. That's not what I want to do. What I can do is put the coefficient. So I put a coefficient of 2 there, saying that I have 2 water molecules. So now that changes my number of oxygens to 2, but it also changes my number of hydrogens to 4. So now my oxygens are balanced. So I have 2 oxygens here, 2 oxygens there. That's good, but my hydrogens became unbalanced when I balanced my oxygens. So I have 4 on my reactant side, but I only have 2 on my product side. So what I just do is I put another 2 there. So now I have 2 times 2 hydrogens, giving me a total of 4 hydrogens. Now my hydrogens are balanced. I have the same amount of hydrogens on both sides, 4 and 4. And my oxygens are balanced. I have the same amount of oxygens on both sides, 2 and 2. And you may be thinking, well, in front of this oxygen here, it's blank. You can leave it blank, or you could put a 1 there. Either way, it doesn't matter. But now we have our balanced equation. Okay, so some of you may be thinking I'm still lost. So I have a couple more examples. I have 2 more. One is just pictures, so you can actually see the molecules and kind of hopefully see what I'm kind of talking about. And that's what I want to show you next. Okay, so here's our chemical equation. CH4 plus O2 producing CO2 and H2O. And then they actually have the pictures underneath. So that would be methane, which is the black atom. Here is carbon, and then you have 4 white, those are each hydrogen, plus O2, here's 2 oxygen atoms bonded together, producing CO2. Remember the black one is the carbon, there's 1 of them, and the 2 oxygens, 1, 2. And then you have your water, which is 1 oxygen, the red one, and then the 2 white, remember white is hydrogen, so I have 2 there. So if I look at the carbons first, I have 1 carbon on my reactant side, and then I also have 1 carbon on my product side, and those are actually already balanced for me. If I look at my hydrogens, I have 4 hydrogens here, 4 white ones on my reactant side, and then on my product side I have only 2 hydrogens. So that's a problem. They're not balanced. 2 and 4 is not balanced. They're not the same. So I'm going to need another oxygen molecule, or excuse me, water molecule. So I have my water molecule here, which is another oxygen and 2 hydrogens. So now that brings my total here to 1, 2, 3, 4. And you can see I put it now a 2 in front of my water, saying I have 2 of these water molecules now. And now I have 4 oxygens on this side, if I count. You may be thinking, oh, well, you only have 2 oxygens, 2 red ones here. Well, don't forget these 2 on this side here. This is all together on my product side. So I have 2 oxygens here, plus these 2 here, giving me a total of 4 oxygens. On my other side, though, my reactant side, I only have 2 oxygens, 2 red ones. So I need to put a 2 in front of my oxygen here, bringing my total now up to 4 oxygens. So if I look at this, now it's all balanced. So I have 1 of my methane plus 2 of my oxygen, 1 CO2, and then 2 of the water molecules. And going back to the original picture, remember in front here, like I said, you can leave it blank. If you only have 1 of them, you can leave it blank, because remember we don't really need the 1s. We just assume it to be 1. And so both these are assumed here to be 1, and then we have a coefficient of 2 in front of my oxygen, coefficient of 2 in front of my water. Okay, so my final example here, you may want to pause it real quick and just write this down. You may be looking at this and saying, oh, this is too hard, this is too difficult, all these letters, all these numbers, and get real frustrated. I'm going to show you a little trick. And you'll see that this one will become one of the easier ones once we get practice. It may not be easy at the end of this video, that's okay, but as we go along and as we get more practice, the ones like these are going to be really easy for you to do. So the first thing that I want you to kind of think about is just going to each individual atom at a time and just balance one atom at a time. So if I look at Mg, so I'm only looking at Mg now. So Mg here, I only have one. Yeah, I know you see this 2. That 2's with the OH. There's only one Mg here. So I only have one Mg here. Look on my other side, my product side, I have one Mg here. So the Mg's are already balanced. I don't even have to mess with those. Then I go to the next one. And here's my little trick. If you have a polyatomic, like OH, treat it as one thing. How many OHs do I have here? Well, I have 2. I have 2 OHs here. Cool. On the other side, here's my OH again. But there's only one. That's not balanced. So to make it balanced, I just put a 2 in front of my AgOH, and that's going to bring my 1 up to 2, because 1 times 2 gives me my 2 OHs. So now I go back, and my magnesium, that's still balanced, 1 and 1, still balanced. My OH is still balanced, 2 and 2, so I can go on to Ag. Now looking at Ag, I have 1 here, and if I look at this side, you may think, oh, I only have 1 there, they're balanced. That's not true. Remember, you have a 2 here. So you have 2 times the 1 Ag, so you really have 2 Ags. Okay, that's not a big deal. So I have 2 on this side, I need 2 on the other side, so I just multiply this by 2. So that brings my Ag up to 2. Cool. Did it change anything else? Well, let me check. Magnesium 1, that's balanced. OH2, OH, there's still 2 of them, that's balanced. Ag2, Ag, there's 2 of them there, that's balanced. Now all I'm looking at is my NO3. And since I have it on both sides, NO3 here, and I also have NO3 there, all I have to do is just balance the NO3s. Well, if you're looking at this, you may be thinking, oh, I have only one of those. No, you have this coefficient, just like we did before. So you have 2 NO3s. On the other side, you have NO3 here, and you may be thinking, oh, I only have it 1 time. No, you got this little subscript, meaning 2, so you have 2 there. So that one's already balanced. You don't even have to mess with that one. So going back through, making sure everything's balanced. My magnesium, 1 on this side, 1 on that side, balanced. Hydroxide, the OH, 2 here, 2 there, balanced. Ag, I have 1 here, or excuse me, 2, and 2 on the other side, balanced. And then the NO2 we just balanced, and we have 2 there, 2 there. So we do have blank spots. Again, you can fill them with 1s. If you like everything to have a number in front, that's fine. And that's our balanced equation. So I want you to try your best on your work. Again, we're going to be practicing this a lot, so if you don't get it right now, that's okay. I still want you doing the work and practicing, so when I come back, we'll be able to answer any type of questions that you have. We'll have a lab over this. We'll really dig in deep on this, and I'll make sure that everybody is able to do it. So again, if you need to watch the video again, please watch it. It's on my YouTube channel, Mr. Coach Beck's Class. Thanks again.